Experiment E19, Effective Setting of an IDMT earth fault relay. This experiment consists of 3 parts. Part A, magnetization characteristics of CT. Part B, impedance of earth fault relay. Part C, settings of earth fault relay. These are the equipment for Part A. An extra low voltage supply via an auto transformer. An unmounted protection class CT. CT ratio 2500 to 5. We may use a multimeter to measure the DC resistance value of the CT. A 1200 ohm rheostat. 2 multimeters and some connecting cables. Then we may connect all these equipments according to this circuit diagram. First, we connect the CT to this multimeter, which will be used as a voltmeter. Then we connect the power supply to this multimeter in series, which will be used as an ammeter. And also connect the rheostat in series. And complete the circuit. And switch the multimeter to 200 milliamp range and the other multimeter to 200 volt range. The circuit is ready. Now we can start the measurement. Turn on the extra low voltage supply. Raise slowly from 0 to around 2 volt. Take a record of the voltage and the current values. Then we can take the next set of data, raise the voltage to around 4 volt. Once again, record the voltage and the current values. Repeat the measurements for steps of about 2 volt up to 10 volt, and then steps of 5 volt up to around 60 volt. This is the last set of data for Part A. Part A measurement results are summarized in this table. These are the equipment for Part B, impedance of earth fault relay. This is the IDMTL earth fault relay. The plug setting range from 10% to 40%. The plug setting of this relay is now set to 10%. Therefore, the current setting of the relay will be 10% of 5 A, that is 0.5 A. This is a step-down transformer, a rheostat. The resistance value is 6.4 ohm. We can now connect the equipment according to this circuit diagram. The ammeter is switched to a range up to 10 amp and the voltmeter is switched to the range up to 20 volt. Now we may switch on the extra low voltage power supply and adjust the current to a value around 0.05 amp. Record down the data and take measurements for steps of 0.05 amp up to 0.5 amp, which is the current setting of the relay. We have collected the current and voltage values for the plug setting of 10%, that is, current rating 0.5 amp. Now I'm going to switch off the power and change the plug setting of the relay to 40%, that is a current rating of 2 amp. I am going to repeat the same measurement for a current value from 0.05 amp up to the current setting value of 2 amp. So we have collected the current and the voltage values for plug setting of 40%. Now I'm going to change the plug setting back to 10%, but I will also change the time multiplier from 1 to 0.1. Repeat the same measurement for a current value of 0.05 amp up to 0.5 amp in a step of 0.05 amp. We have finished all the measurements for part B. The measurement results for part B are summarized in these tables. This is the experiment set up for part C. On the right-hand side, we have a current supply through an isolating transformer, and its current value can be adjusted by the auto transformer on the left-hand side. In the middle is a current transformer with a rating of 2500 to 5. The current transformer is connected to the earth fault relay that we used in Part B, and the relay will send tripping signal to the contactor in this control panel. In this part, primary current of the current transformer is derived from the auto transformer and the isolating transformer. It could be dangerous to inject a primary current as high as 2500 amp to the current transformer. Therefore, we have made 5 primary cable loops to create 5 times of magnetic field of one cable. So, when the current in the cable is 500 amp, the current sensed by the current transformer will be like 2500 amp. In this part, we will test the tripping characteristics of the earth fault relay with different current injection values to the current transformer. In the first set of data, I will use around 115 amp. When I switch on the circuit connecting to the earth fault relay, this current value will drop to around 100 amp. So when the current in the cable is 100 amp, then the current in the primary of the CT will be 500 amp, and the CT has a turn ratio of 2500 to 5. So the secondary current of the current transformer will then be 1 amp. I have just switched on the circuit connecting to the earth fault relay. You can notice that the reading of the current now dropped to around 102 amp. When the circuit to the earth fault relay is switched on, the disc will start to move. When the moving contact touches the fixed contact, then a tripping signal will be sent to the contactor and trip the circuit. I use a timer to measure the tripping time of the earth fault relay. You can see the disc of the relay is now turning. When the moving contact touches the fixed contact, a tripping signal will be sent to the contactor and trip the circuit. After the circuit is tripped, you should turn off the circuit, reset, and turn down the current value to 0. Then we can repeat the above procedures for larger current. We will take measurements for current from 100 amp to 500 amp for steps of 50 amp. This is the tripping time measurement for current reading of 500 amp. You can see the disc moves much quicker. The measurement results of Part C are summarized in this table. You may plot the data onto this graph to check if they comply with the specification.